equations is you can always check your answers, right? We can always go back and plug them in and see if it works. Our strategy on these types of problems is going to be to get the radical by itself and undo it. If you have a square root, what would you do to make a square root go away? Square. If we had a cube root, how would you make a cube root go away? Cube. Okay, but the key is you can't just go through and cube each individual term or square each individual term. You have to do the entire side of the equal sign when we do that. So let's say I gave you this problem. All right, we're looking for real solutions only, so we're not dealing with any kind of imaginary thing here. We have to get the radical by itself first. So we have to start by adding this 2 to the other side. Then the opposite of a cube root is a cube. So we cube each side. Cube root and cube cancel. So the third is 8. And then we solve. So at this point it's just a linear equation, so you add over your 4.
Yeah. I might be able to do that.
So you've seen these before. We'll add a few things to it that maybe you haven't done, but the basic concept you've done.
Algebra 2 and this is like
They're very
a
similar.
repeat.
This takes it a little bit further than you go in Algebra 2. Like Algebra 2, you're just going over the surface of all of it, and this
I feel like then calculus is a big jump.
I mean,
I'm not taking that.
it's just different. Okay, one thing you do need to make sure you do on these problems is check your answers. There are times when you might have something that you get for a solution and it doesn't work. Like we talked about yesterday, if it's an even root, it has to be positives underneath. So there are some issues with that. So if you plug in a 6, we get 12 minus 4 is 8. Cube root of 8 is 2 minus 2 equals 0. So it does work. If it doesn't work, then we just say no solution.
I actually find a blank page.
How do you function?
Why don't we go back to my
Oh wait,
I have a
Mine's not order.
wait.
mine used to be in order. And then
I've had stuff we did at the beginning of the year.
then
Mine
it
is this
stopped being in order.
Mine is now in order for.
And then I just dog ear the pages
Alright, silence is good.
of the important ones.
All right, we ready? So here is your problem. So what'd you do?
Cube,
Cube each side.
both sides.
All right, so we have 2t minus 1. 1 to the third is 1. Paying attention to me?
Yep.
Add over your 1 and t is 1. Did you check it?
Yep.
Did it work?
Yep.
Yep.
Okay, so we're good with those kinds of problems.
I think
Let's take a look at this one.
oh yeah,
Yeah, flow.
All right, good. So when we go through to get rid of a square root, we square, but we have to do each side. So on this side, those cancel, and we have x minus 1. And then to square on the right, you square that entire thing, that means there's 2 of them, so you have to FOIL. So you get x squared minus 7x minus 7x is minus 14x.
plus 49.
Make it all on one side.
So we'll subtract our x and add our 1. All right, multiply to 50 and add to negative 15.
That is 2 minus 12.
Set them equal to 0, so we get 10 and 5.
I'm the
the very original. So, if we check the 5, we get the square root of 5 minus 1
Yeah, that's right.
10 does not work.
equals 5 minus 7. So we have the square root of 4 equals negative 2.
No,
No, that doesn't work.
neither.
If we plug in 10, we get the square root of 10 minus 1.
Did not have solutions.
So we get the square root of 9 equals 3,
Which is insane.
and that does work.
Which is silly.
All wrong.
So 10 is our only solution.
Whoever told us wrong.
S&P
All right.
is down 2%.
Hmm.
S&P is down 2%.
That's lovely. Any questions on this one?
Whatever you do, don't invest on Amazon. For Amazon, right before Black Friday.
Okay,
It's not work out.
good to know.
You know from experience?
Well, we played the stock market game in the swallowing spot. It's not work out for me. I lost very lot.
Very lot. Alright, let's take a look at this one.
Square.
Man, you have to like square.
Okay, we have a lot of radicals going on. Our strategy, we isolate our radical. So let's just focus on one at a time. So if I'm looking at this outside radical, if I square each side, so what happens is when I square the left, it cancels the radical on the outside, and on the right, it cancels this. So now I have 2 times the square root of 7x plus 2.
You got squared again?
We have to square again. Okay.
Oh, we have to follow that. No.
So, squaring means there's 2 of these. Alright? We have to square everything. So what's the 2 squared going to be? 4 times, when I take the square root of 7x plus 2, square it. On the right, there are 2 of these. So we FOIL, so we get 9x squared plus 12x.
Okay, shoot that.
Alright, so if we subtract over, so if I subtract my 28,
It's -2.5.
subtract my 8, what do we have to do now? Flip it. What multiplies -36 and adds to 16? 18 and 2?
Yeah. But one of them has to be negative 2.
Negative 8.
Oh, yeah.
Gotcha.
Divide by our 9. So we get x minus 2. 9x plus 2 equals 0. Set each of those equal to 0. We get positive 2 and negative 2x. And then, what do we do? Check it. So when you check, always go back to the very beginning to plug those in. Plug in a 2. And you're welcome to do this on your calculators.
Perfect. I forget the rule.
So I get the square root of 8 equals the square root of 8, so that's good. What was my other one? Negative
2 and 9.
So this time they both work.
Perfect.
Alright, I'm gonna give you guys a problem to try.
Okay.
It's been a while.
Heavy brain.
Alright, so we add over the x, and then to square, we have to FOIL on the right. So you get 11 minus x equals x squared plus 2x plus 1. Add over your x, subtract your 11. So what multiplies negative 10 and adds to positive 3? Okay, set those equal to 0. We get negative 5, positive 2. Right. If you plug in the negative 5, you get yeah, 16 minus negative 5, so that doesn't work. But the 2 does work. So 2 is our only. Alright, are these okay with everybody?
I did not touch him.
Alright, let's talk about this problem.
Ew.
This one is going to be a little bit longer. Because we have multiple radicals.
Do we have to add one over and then square?
Yes, because here's the problem. If I try to square as it's written, if I just squared right here, then we end up foiling with these radicals, which we can do, but
You don't want it.
yeah, that's not going to be pretty. Okay, so let's try. Okay. So if I add this over, now when I go to square, we can't do individual terms. It's each side of the equal sign. So pay close attention here. On the left, square root and the square cancel, and we get 2x plus 3. On the right, this is 2 terms, which means you have to FOIL.
Hold on. I thought we had the one. There was one up there where we just turned it to a 4 plus.
Yes,
Why couldn't we just do that again?
because this one there was no other term added to it. We didn't have a number outside the radical that was added. It was multiplied, which was different. Okay, so let's look at what happens when you FOIL. 2 times 2 is 4. Okay, when you multiply this 2 with the radical, the 2 just goes on the outside. So it's 2 radical x plus 2 plus 2 radical x plus 2. So that gives us 4 radical x plus 2. When you take the square root of x plus 2 times the square root of x plus 2, what happens to the square root? Alright, so we will. Let's get this radical by itself. So can I subtract over my x? So I get x plus 3 equals 6. So then if I
Subtract over your six.
subtract my 6, x minus 3 equals 4 radical x plus 2. Alright, now this is like a problem that we've done before. So we square each side. Will I have to FOIL on the right hand side this time?
No. Left.
The left we FOIL, the right we don't have to because it's one term. So, x minus 3 times x minus 3. get x squared minus 3x minus 3x is minus 6x plus 9. What do we get on the right?
Right.
Good news is this is the hardest problem that we have,
I didn't think about that.
and the longest. Alright, so if we subtract over the 16x, subtract over the 32,
And then all the way back to the original problem. Look back there.
I see the original problem.
Yeah, I think I read it.
I subtracted the 6 over, and that's why it became a minus 3.
Oh, but the one doesn't work.
Okay, so 23 is negative 1.
No, it's not.
So if you plug in 23,
It works.
23 works, you get square root of 49 minus square root of 25,
Oh, and then
which is 2,
So it's minus 5.
and negative 1, was that the other one?
Yeah.
You get the square root of 1 minus the square root of 1, does that equal 2? No. So 23 is the only answer.
all that work is for one solution.
I know, it's a lot of work. Alright, is that okay? We probably need to do another one of those. Do you want to try it on your own first? Okay.
It's game day grand camp. Oh, I think I figured it out. It's
Alright.
5 and 1, and then I'll get my house. What, 2?
Let's look at it.
I got
So you add over the square root of x minus 1. Then we have to FOIL. Guys, stop talking. So when we FOIL, 2 times 2 is 4. Plus 2 radical x minus 1 plus 2 radical x minus 1 is 4 radical x minus 1. And radical x minus 1 has radical x minus 1 that drops the square root. Okay, so we have 3x plus 1 equals 4 radical x minus 1 plus x plus 3. We add those like terms. So if we subtract the x, subtract the 3, we get to here. Are we okay to that point? Now what do we do? Square it again. Alright, so on the left, you have to FOIL because it's 2 terms. So we get 4x squared minus 4x and minus 4x is minus 8x plus 4. Over here, 4 squared is 16, square root of x minus 1 squared is just x minus 1. So if we subtract over the 16, add over the other 16, What do you notice about all of those?
Greatest common factor.
Greatest common factor of 4. You can either factor out the 4 or divide it on each side. It doesn't matter. So, what multiplies to 5 and adds to negative 6?
It's still 5 and 1. That's it.
Alright, does 4 ever equal 0? No, so that doesn't give us any solution. If you set x minus 5 equals 0, you get 5. If you set x minus 1 equals 0, you get
And they
1.
They both work.
Both work. I'm going to trust you on that. So we got 2 answers, 5 and 1.
So we don't have to think about this one.
No, I still think that.
No,
Multiply over to the 20.
yeah, and 4.
That's just a lot of extra work.
So this one?
Alright, let's do. So I want to do another type of problem.
I love you just like took up half my page.
For real. I don't care though. I don't care, Mr. Reynolds.
Thank
I
you.
was just pointing it out.
You're not complaining,
I was just
right?
pointing it out.
Yeah.
Okay, let's do.
But if we get like stray away from those kind of problems.
Yep, I'm going to do a different type.
Or stray away from their
Like,
mind.
the fraction of the just turn it into a radical.
Fractions are the easiest.
You just turn it into a radical.
Get out. They're the easiest.
Okay. There are 2 options for this problem. One
like
is
terms.
going to be a lot easier than the other. Okay?
You have cosine of the-
Add, can you add like terms?
If there were like terms, you could. The exponents are different. So one option would be to write this with radicals. Okay, you'd have the cube root of y squared, the cube root of y, and the 6. But here's the problem. Because then to cancel that cube root, you'd have to cube, right? And you would have to have that same principle
Foil
3 times. So it will get ugly. Well, let me ask a different question. If I gave you x squared minus 5x plus 6, what would you do to solve that? Easy method. We can do the easy method with this.
Oh, yeah.
It's a quadratic type. We have a 1/3 and a 2/3. If you have y to the 2/3 and you put half in each parenthesis, what do they each get? 1/3.
You know, it's pretty swagalicious.
All right. What multiplies to 6 and adds to negative 5?
You doubted me for a second. You froze
No,
me
I
down
didn't.
my
I
answer.
was just giving everybody a chance to catch up.
That's not good.
All right. So now if we set each of those equal to 0.
You need to multiply by 3, right?
At this point, it might be helpful. If you want, you could change your 1/3 to a cube root just to show yourself what you're doing. So if you add your 3 over, then to cancel a cube root, you would cube. So you get y equals 27. And there's the cube on this. We get 8. So, the reason we're able to do this, if I look at my exponents, if you have 1 and half of that gives you the second one and a constant, that's like a quadratic.
Is there any times we can't do that? Okay, we'll cube it.
I probably wouldn't.
It's kind of like human torture, I feel like.
I probably would not make you do like a
Child
cube
labor.
one that sort of way. Alright, let's try,
Wait, do we have to check these?
yes, we should check them.
Ah.
Grab your calculator and just plug them in.
Sorry, guys.
I think
You're
they
not sorry.
I am sorry. I feel bad now.
we should always check.
I just cleared my whole problem out. I'm not doing it anymore.
$27.
That's crazy.
27 works. And so did 8.
Alright, so both work.
Well, I was gonna help, but
Someone else should do 8.
it's too late.
Alright, I want to do this problem.
a funny fraction. I like those.
Or, we're gonna have
So do we?
So it's still half.
Or-
Could we, yeah,
Or
it's
slip and
still
slide,
like a
you said.
quadratic, isn't it? So could we do slip and slide?
Ooh, yeah.
Alright. So 6 times 15 is 90. So if you factor that, x to the negative 2, what would that break into? Negative 1. Notice this variable right here should always be what your middle term is. Multiply to 90 and add to 19. Alright, then we need to, okay, 9 over 15 reduces to 3 over 5. So it's 5x to the negative 1 plus 3. 10 over 15 is 2/3. So 3x to the negative 1 plus 2. Alright, if I set each of those to 0, what does a negative 1 mean?
Flip it over.
what? I mean,
Make it a
what-
fraction.
Yeah, this is just like 5 over x.
Oh, these are easy to solve.
Yeah. Subtract over your 3. Then you can multiply your x over. So we get negative 5/3.
Yeah. Yeah, I lied, it wasn't easy to solve, it really was.
Okay, where'd I lose you?
I multiplied numerator.
Oh, instead of denominator.
I also thought you were supposed to multiply.
Yeah, you always multiply by what's on the bottom. Alright, I'm just going to save you time and tell you both of these do work. Because we know we can check them.
And
to
you
see
For
if
a
they
top G.
Alright,
Alright.
so can I do one final type of problem and then that's it, and then we will have a work day tomorrow? Would that be okay?
Yes.
Okay,
Type of problem.
Wait, can I clarify, is it one problem or a couple of the same kind of problem?
it depends on if you need more than one.
Yeah, I don't need that, right?
It's gonna be the most confusing problem we've ever seen.
You can just tell by a smile on her face.
Okay, let's do this.
She's luring us into a trap.
Good way to
Let's
put it.
say I gave you,
Even if you're confused, do not ask.
Just act like you know what you're doing.
Just put your hands up like this direction, that was tell you what you want
x
Or nay?
to the, work out
If that's what you're thinking, is one thing of the problem, you should have me.
Is that a 5 or an 8?
x to the 7/5 minus 4x
I'm just interested if it's half. Cause it gotta be, just show her what half is if it's this.
to the
Oh.
Hello?
negative,
She just wants to do more
3/5
problems. No, it works.
over x.
Over.
Alright, so part A,
Multiply the x over.
I want you to write the expression
Difference of squares.
without negative x. Okay. So what we're going to do is first focus on the top of this fraction. Okay. There are a couple different ways of going about this, but I think the easiest would be greatest common factor. So when we do the greatest common factor, we always take out the smallest exponent, right? So if you look at 7/5 and -3/5, which one is smaller? So we will factor out x to the -3/5. Okay. If I take that out, when you factor out, so if I had said like x to the 5th minus x cubed, you would take out x cubed. What's that first exponent become?
Square.
That's x squared because you subtract those exponents.
It's the same thing.
So if you subtract these exponents, that means you have 7/5
It's 2.
minus -3/5, which gives you 10/5 or
That's 2.
2. Minus, on this one we took out all the x's, so we just have the 4.
This is why I should have thought.
And then, what do you do with negative exponents? Where do negative exponents? Okay, so I have to take this down to the bottom. This is an x to the first. When you bring that down, it brings that x to the 3/5 down here. So what do you do with those exponents? Add 1 plus 3/5. Okay, that's my answer to part A.
Wait, you know, two? You know, they,
No.
Difference squares.
you just wait.
All right, part B. Let's go back, just because I don't want to rewrite it. I'm going to say equals 0, and then part B I'm just going to say solve. Okay, so I have now turned this into x squared minus 4 over x to the 8/5 equals 0. And I want to solve that. What would you do to get rid of the fraction? Multiply by the denominator. What's 0 times anything? So then what would you do? You can either add the 4 over and do the square root method, or difference of squares, x plus 2, x minus 2. So x is,
-2 and 2.
alright, that wasn't too bad, was it? Do we need another one of those?
No. That's
Okay.
Maybe-
So I am posting a math Excel assignment. In fact, it should be open now. We will have time in class tomorrow to work on this as well.
I'm so happy for you, Caitlin. It's not as if I know both sides of the system.